Now, I just want to go over to Moodle for a start. Just point out some new resources there. So today we're going to start a new topic called CI/CD, or Continuous Integration, Continuous Deployment, which is this topic down here. And this week's lab is going to be on end-to-end testing. So the stuff we covered last week, that's Cypress framework. And thirdly, not sure if it's good news or bad news, but thirdly, I have published the specification for the first assignment. And I'll talk about that tomorrow morning with you. So tomorrow morning, I'll start off with a Zoom meeting where I'll discuss it, and then you can work away on the lab for this week. So for today, anyway, we'll go back to our new topic, which is CI/CD. So you'll get the slides here if you need them. So this is another key practice within the Agile software development methodology. And again, the typical scenario that you face yourself, or that you find yourself in, is you're a member of a large software development team. You may not actually be located in the one physical location, maybe disparately located. Each member is contributing some code. They're developing a feature or fixing a bug. Either way, they're contributing some code and accompanying tests. As we know now, every time you write some new code, you need to write a new test to make sure that the code works. But we need to eventually integrate everybody's code into the overall application. Now, we can't do that kind of on the end of the week. We do integration, or the end of the month, as it used to be once upon a time. This idea of integrating individuals' code into the overall project, that really has to happen in a continuous way, hence the name. In other words, many times per day, possibly, some team members' code is integrated into the overall application, whatever state the application is currently in. Now, we saw last week in the lab that you did on pull requests. So pull requests is GitHub's way of controlling the kind of physical integration of individuals' code into the code base. But that's not enough, really. Once we bring somebody's code into the code base, clearly we need to run all of our tests again on that code. And also we should probably deploy the application into an environment that is as close as possible to the production environment. And that deployment essentially needs to happen every single time somebody integrates, or every time somebody's code is integrated into the overall application. And it cannot be a manual task. It has to be automated. Everything that I talk about is about automation of as many aspects of the software development lifecycle as possible. And equally, continuous integration needs to be automated. The second part of this title, continuous deployment, that relates to how you release, I suppose, how you release new code into the production environment. And we'd like that to be fully automated as well. So that's what this whole area is about. Now, unusually, start with a definition. I'm going to talk about continuous integration today. I'll say a little bit about the continuous deployment, but the main focus is continuous integration. And so this definition, which is a definition from a person called Martin Fowler, who would be a well-known expert in the kind of software engineering field. So he defines continuous integration as a software development practice, so that's good. That's part of what this module's title is about. Software development practice where members on a team integrate their work frequently, i.e. daily. So each individual team member may actually carry out an integration multiple times per day, leading to multiple integrations per day. That's fine. But it's not just as I said there at the outset, it's not just a case of bringing an individual's code into the overall application source code folder. It's more than that. We're saying each integration needs to be verified by an automated suite of tests, by an automated build. Build kind of refers to not just automated testing, but for many applications, they need to go through I suppose you'd call it just a build step. In the case of, if we talk about a React application, the source code that you write for your React application, you can't really deploy that source code in that form for production into a production environment. It has to go through a build step. Now, you have not done that. We will do it in this module. In the case of a React app and a JavaScript app, it's referred to as bundling. But for other types of applications, let's say if you were developing a Java application, then the builds would relate to compilation, obviously, but also the packaging of all of the source code into probably a jar file. We do a similar type of packaging for JavaScript as well, but we'll talk about that some other day. I don't want to get involved in that today. So there is this notion of building your application every time somebody integrates their source code into the overall application source code. The application needs to be built, and building not only refers to this kind of compilation and packaging step, but also it includes running automated tests. So it would be our probably end-to-end tests and unit tests. All of that has to happen every single time somebody integrates some source code into the application. And so at the beginning of this definition, I'm saying that happens multiple times per day. So there are multiple builds, automated builds happening per day. And again, you cannot let that be a manual task. That just has to happen in an automatic fashion. So we need to see how can we achieve that. And the whole point of doing this integration and automated build continuously is obviously to detect any errors as quickly as possible, because the sooner you detect an error, the cheaper it is to remove it and debug it and remove it. Another definition kind of focuses on what's the whole point of this? The whole point of this is to try and ensure the quality of the software that you're producing. And again, that relates to this idea of the quicker you identify bugs, obviously the fewer bugs in an application, the better its quality. So it's just coming at the same issue, but from a quality perspective. So how do we achieve continuous integration? Well, we actually know a lot about this already. It's a lot of what we've been doing up to now. So going through to the points 1 to 6, number 1, it's really important to have a single source of for the repository, or to have all your source code in a single central repository. Okay, that probably means one GitHub account, one GitHub repo that everybody has access to, be it via pull requests or maybe they're given more access via what's called a collaborator. I didn't look at collaborators in relation to GitHub, but it's another form of sharing a repository. But anyway, we need to have a single central repository that everybody has access to. So we know how to do that now. Number two, automating the build tasks. We'll talk about that maybe some other day. But there must be some automated way of compiling and packaging your application into a single deployable unit. But build as well. Build also includes tests, automated tests. So we know all about that. Number three, everyone commits every day. So that's okay, in quotes, I suppose. But once you have completed, as a member of a team, once you've completed whatever task has been assigned to you, then you integrate it straight away. Number four says that, we don't want to do this automated building on our local machine, or maybe the team leader does it on their local machine. The automated building, in other words, the continuous integration, has to happen on some server that everybody has access to. So it has to be carried out on, I'm going to say a remote server, but at least it's on a server that all the team members potentially have access to. You don't want it carried out on somebody's individual computer, which only that person has access to. Now, what we will do is we will use a cloud service as our CI machine. So that has the same effect, really. And number five, keep the build fast. So obviously you don't want this automated build and running of the automated tests. You don't want that to take certainly hours. It needs to happen in a period of minutes. And one way of improving the speed of the whole automated build is to have caching. So if you think about our JavaScript applications, when we do an npm install, that's usually the slowest part. Well, if we cached all the third-party node modules so that they did not have to be reinstalled every time we do an automated build, that would obviously improve the speed. And I'll show you how to do that using the particular continuous integration cloud service that we will look at. And number six, test the application. Oh yeah, so the last part of once you've done an automated build, then and maybe done some automated testing, what you should also do as part of the continuous integration practice is to deploy your application on a server that is configured as close as possible to the production server where the application will eventually be available to your end users. Now that is often referred to as the, do I mention it there? Test the application on a clone of the production. I don't mention it there, but that clone is often referred to as a staging server. I think I mentioned it in a later slide. But either way, we need to deploy our application onto a server that is configured as close as possible to the production server that it will eventually be deployed to. And the last point, number 7, is make it easy for everybody to get access to the latest executable. So, we at an earlier stage there in one of the point number 2, where we build a deployable version of the application. Well, that deployable version, it's packaged in some way. Each team member should have access to that so that they can download it onto their own computer and play with it, essentially. Number 7, okay, I've covered that. And number 8, make the process transparent for everybody. Everybody should be able to access the results of every automated build and every automated deployment to your staging environment. Everybody should see what the outcome was. Maybe the build failed, maybe the deployment failed, whatever the result was, everybody should have access to the results, because their code may have been the cause of that, and so they need to be able to see the results. That's the how. The why, I kind of mentioned it already, but quickly to go down to them. Why do we have continuous integration at all? We want to be able to detect problems early, because always the earlier you test things, the cheaper they are to remove. We want to find and remove bugs early, that's fine. Reduce the risk of cost, schedule, and budgeting overruns. That's kind of linked to point number 1 and 2, really. Number 4, increase project visibility. The visibility refers to what happened as a result of each new integration. That was kind of mentioned in if I go back to the previous one, the last point there, point number 8. So the visibility is the visibility of the whole continuous integration process and the execution of that process, the multiple executions of the continuous integration process. The results of those should be accessible to everybody, and that's what we mean by visibility, really. Number 5, deliver new features and get users' feedback. That's the whole point. We want to try and get new features out to our end users as quickly as possible so we can get feedback from them and improve them. And continuous integration certainly contributes to that. Number 6, improve the team's cohesiveness. That's fine. Everybody has access to the continuous integration server results. So, and number 7, have greater availability. Number 7 means you always have a version of the application that can be deployed to wherever. Okay, that's always a good thing. Maybe your customer, if you're developing an application for an actual customer, you may suddenly get a telephone call from them and they want to see, what's the most, can you give me the most recent build of the application, deploy it onto a particular server for me so that I can look at it. And continuous integration kind of guarantees that you always have the most up-to-date deployable working version of the application. You obviously don't give them a version of the application that caused the continuous integration process to fail. But this slide is pretty much saying the same thing as the previous 2 ones. It's just a nice kind of catchphrase. The whole point of continuous integration is to produce better quality code, produce it quicker, and produce it more cheaply. So I won't go through those points. That's continuous integration, continuous deployment, then the kind of CD part of CI/CD. Well, the CD kind of stands for 2 things, really. I don't know why. Well, I suppose there's a good reason they didn't call it CI/CD/CD, but the CD has 2 different meanings, and they both apply, really. It's not one or the other. So first of all, I'll define what continuous delivery is. Continuous delivery, I'm saying there, is the development discipline. So it's another kind of practice or discipline where you build software in such a way that it can be released to production at any time. Now, the key point here of continuous delivery is that the newest build of the application, it can be released to production at any time, but it doesn't happen automatically. The decision to release a new version of the application to your production environment and hence make it available to your end users, that's a decision that is made probably by the project manager or team leader, and they kind of press the button that causes a particular new release of the application to be deployed into the production environment, but it's a manual step. So continuous integration produces new versions of your applications regularly, like multiple times per day. Now, there may not be a huge difference between one version of the application and another version of the application on the same day, but there will be minor improvements, obviously. It may be bug fixes, it may be partially complete features or whatever. But the decision as to whether that version of the application should be released into production, that step, if you like, is a manual step. That's continuous delivery. Continuous deployment then is where that final step is actually automatic. So once your application goes through a full continuous integration cycle, then assuming nothing went wrong, then automatically the new code is deployed into the production environment automatically. Now, clearly, only software houses that have practiced continuous integration and continuous delivery for a number of years would actually then progress into a continuous integration, continuous deployment mode, if you like. So it's obviously, you know, it's a risky step if you automatically update your software in your production environment, if that's just happening multiple times per day, potentially. But there are software houses where that is actually the case. So that's continuous deployment. Why is CD, whether it be delivery or deployment, how do we achieve it and why is it important? Again, there's a little bit of repetition here maybe, but as to answering the question, how do we achieve continuous delivery stroke deployment? Well, first of all, we have to have continuous integration in place. That has to be a practice that has been part of a software house's software development lifecycle for a number of years. So it's a very finely tuned practice before you can ever even start thinking about the CD area. Number two, you run your automated tests. That's okay. I mean, that's implicit in continuous integration, I suppose. Number three, you deploy the application to a production-like environment termed a staging environment. So that has to be something that happens every time we do continuous integration. We actually deploy the application into an environment, presumably some server, that is configured almost identical to the production server. And so if it deploys correctly to this staging server or staging environment, then we could be, and presumably once we deploy it into the staging environment, maybe we subject the application to some more automated tests. And if it passes all of that, then we've got a lot more confidence in actually deploying it into the real production environment. So you've got to have 1, 2, and 3 in place if you were to say that we practice CD properly. And the why then, again, kind of some certain amount of repetition. We want to reduce the deployment risks. If we are deploying our application into a staging environment, then we know that once we deploy it into production, there is less likely to be any issues. And that's obviously a good thing. Number two, we change the version in production more rapidly because presumably every new version of the application is an improvement on the previous one, whether that be less bugs or more features, and that's good for our end users. We can release number three, we can release new versions of the application at the press of a button. That's kind of the continuous delivery kind of idea. And number four, well, we can get feedback from the users because we're now exposing them to new features in a speedy fashion, and feedback is always good. So this is kind of a representation of what CI/CD is all about in a kind of graphical way. I got this somewhere on the web. I was going to doctor it to suit the kind of language that we're using, but I said I'd leave it as it is. So it's comparing CI versus CD, where CD stands for continuous delivery, versus CD, where CD stands for continuous integration. And these are often referred to as pipelines. So the continuous integration pipeline, in general terms now, the first stage, to use the language of pipelines, the first stage is the build stage. That's kind of the compilation, installing third-party modules, packaging the application. If they all apply to the nature of the application that you're developing, then we would refer to that as building the application. And if the build is successful, there are obviously no compilation errors, no linting errors if it's the JavaScript project. All the packaging, the installations of the third-party modules all went clean, and the packaging was fine. Then our continuous integration pipeline moves on to the next stage, where it runs whatever unit tests you may have written. Now, we didn't write any unit tests in the case of a React app, for example, but you can write tests for each component. Component is a unit really in the context of a React app, but you can write component tests. But more generally anyway, you would tend to run whatever unit tests have been built up by the team next in this pipeline. And if that is successful, then we deploy the application to our staging server. And the next thing then is we subject our application in the staging environment. We subject it to acceptance tests. Now, for acceptance tests, you can just substitute here end-to-end tests. So this is where our E2E tests would be carried out. And that's your generic continuous integration pipeline. And all of this is automated. So if you can imagine over here, we have our source code repository. Once that repository, once there is a commit, essentially, once a commit happens to that repository, then this pipeline executes. Continuous delivery, the only difference is over here at the end, right? Once we've ran our end-to-end tests and they were all successful, then the decision to deploy the application into a production environment is a manual decision. I don't know if you can read the word manual there, but that step won't happen automatically. Can you just bear with me for 1 second? I'm going to stop sharing the screen for 1 second, and I'll come back to you in a tick. Right, so continuous delivery is where this step is not automatic. It has to be initiated by the project leader or team leader, I guess. That's continuous delivery. Continuous deployment is where this step is automatic. So there's no manual intervention at all. Right, that just, I think it's a nice kind of visual representation of this kind of practice, if you like. So move on from there. If you're going to have a continuous integration, if you're going to practice it within a software house, obviously you should only do it if it's successful, if it helps the software development process or life cycle. And the only way you're going to know whether it's successful or not is if you measure it. That's the only way we know whether anything is successful, if we measure it in some way and set some targets for it. And the same applies to continuous integration. It needs to be measured. Now, there are lots of measures that you can use. I don't want to discuss this too much now, but just to make you aware of it, I suppose. For example, we could just say the number of successful builds or the rate at which our builds are successful is a measure of how good our continuous integration process is or pipeline is. So in other words, if I go back to here, and by build now, I'm kind of including all of this really, if it breaks down very regularly, whether it be at this stage or this stage or this stage or this stage, if it's constantly failing, then obviously we need to try and resolve what's causing the failure of our continuous integration process. So that's a simple measure. How frequently do we get a successful build? Because remember, we're going to be subjecting our code to a continuous integration pipeline multiple times per day. So if it's failing on a regular basis, that's really no good to anybody. Or you could use the build repair rate as a metric for determining how successful your continuous integration process is. By that, we mean that, okay, obviously your continuous integration process is going to fail sometimes, but how quickly can we actually resolve what caused the problem? That can be a good measure. If it takes us days to resolve it, that's not good. We should be able to resolve it certainly within the day. The total number of static tool errors, well, that refers specifically to the very first stage there, the build stage. If our continuous integration pipeline is always failing at the very first step, that build step, then that essentially means that people are contributing code which either fails compilation or it fails in terms of linting checks, and clearly that's not good. So we need to try and fix that by re-educating the team members, I guess. How good are your unit tests line coverage and functional test line coverage? I'll talk about maybe line coverage, but there is a way of measuring how good your testing code is. Essentially, what line coverage, that's a measure of how good your testing code is. Line coverage refers to how many lines of your source code were not exercised when you ran all of your tests against it. And clearly, you want to try and minimize this. You want to essentially try and ensure that at least every single line of code of your source code has been exercised at least once by your testing code. And there are tools that will carry out this line coverage measurement for you. We may look at them later on. So the overall point anyway is you should decide as a software development house, or maybe even within a project, what metrics are you going to use to assess the success of your continuous integration process. And once you've decided on that metric, then you should continuously measure it and monitor it. And if the metric is going in the wrong direction, find out how you can improve the continuous integration process. It may mean using different tools, using a different continuous integration server, whatever. So pay attention to the bills, that's okay. Do I need to discuss those? I think I've mentioned most of those points before. CI metrics matter because they identify key metrics and track them. I've already said that. Add them, act on them immediately. That's okay. Now, that's a lot of talk really about continuous integration and continuous delivery stroke deployment. So I said there that the continuous integration, you don't really want to be running it on one team member's local machine. You want to run it on a remote server that everybody in the team has access to. And that was the way it was done for a number of years. But today there are a number of cloud services that we can just register on. that are specifically aimed at providing continuous integration platforms for software development teams. And one of them is a cloud service called GitLab. Now, I will be requiring you to create an account on the GitLab service. Now, it does require you to provide a credit card as part of the registration process. That was actually only introduced, I think, last year. I think they introduced it because there were a number of people that were misusing the GitLab service. They were using it for mining cryptocurrencies, and obviously that was consuming a lot of computing power on their servers. So to try and stop that, they forced a registration process that involved providing a credit card. But I'm pretty confident, I'm very confident that you're not really going to incur hardly any, if any at all, costs using the GitLab service. So what is this GitLab service? It's actually a lot more than continuous integration. As it turns out, it can be used for other aspects of software project management. But as its name suggests, it is Git-based, so it does provide a repository. It's essentially an alternative. The repository part of it is an alternative to GitHub, and it has all of the services that GitHub provides. It's open source, that's fine. It's freely available. Well, you still have to provide a credit card, but that's slightly misleading. And okay, it's actually it's very well maintained. Actually, I've been using it now for about 3 or 4 years, and they've done a lot of good work on the UI side of it. When I started using it there again last week. So GitLab is much broader than this continuous integration. There are a number of modules, if you like, that make up the GitLab service. At its core, it provides a Git repository. So that's the kind of alternative to GitHub. Down here, I'm just saying one of the modules is the continuous integration one. That's the one that we're going to focus on. We're not going to use any of the other ones. We're going to use this one, all right, and we're going to use this one. We're not going to use the other ones, but if you kind of scan down through them, it provides a service for tracking issues, an issue tracking side. It provides a user management, so you can manage the different access privilege for different members of your software development team. Maybe you want certain members of the software development team to only have access to the Git repository and not to the CI or whatever. The wiki is where you can host all of your project's documentation. It has a separate Docker container repository. I don't know if you're familiar with Docker or not, but it does. It's very much it's a big fan of the whole Docker and containerized runtime environments. And over on the left, then there are some other aspects to it as well. So it's a full project management platform, really, software project management platform. So we're going to just focus in, as I said, if I go back to here, we're just going to focus in on this one and this one. Yeah. Sorry, drawing isn't great. And in particular, the CI part of it. I mean, there's nothing particularly novel or new in the repository side of it. So I don't need to talk about that. So what it is what the GitLab CI module is, if you like. It's a fully integrated with the GitLab repo side of it. So what will be happening is in the lab, as you see, we will push some source code. We will push source code to a GitLab repo, and then that will trigger a continuous integration pipeline, hence the kind of automation. So it's fully integrated with the repo side, which means that as well as having version control on our source code, we will have version control of our kind of CI. The word build there is used. I'm using the word build in multiple contexts. Apologies about that, but essentially the CI pipeline that we will define, and we define it in code actually, that will be subject to version control just as well as the source code. Provides Git hooks as well. We won't be using those. I've already mentioned point 4. Why code and build, that's okay. Easy to get started with, that's okay. Scalable, it certainly does scale up, although we won't necessarily require that scalability. And that's okay as well. So when we talk about continuous integration, there's a vocabulary around it. I've already used some of the vocabulary. We talk about pipelines and stages and jobs. And so the relationship between these three concepts is a pipeline is comprised of many stages, and a stage is comprised of many jobs. If we go back to the picture that I had there a few slides back, we had a continuous integration pipeline, we had a continuous delivery pipeline, and a continuous deployment pipeline. And each of the boxes in those pipelines is what we would refer to as a stage. And within each of those boxes, there may be multiple jobs or tasks, if you like. So this is how we describe our continuous integration process in terms of a pipeline made up of stages, which is made up of jobs. And that's what I'm saying here. So a pipeline is a group of jobs that get executed in stages. Yeah, so the stages get executed sequentially. Within a stage, the jobs within a stage are executed in parallel. And clearly, if any job within a stage fails, then the pipeline's execution is considered to have failed. It won't execute the subsequent stages in that pipeline, which makes sense. Now, in the case of the GitLab CI platform, how do we define our pipeline and its component parts? Well, we actually define it inside a configuration file of type YAML. And so if I just flip over to the Movies app, because we're going to use continuous integration in the context of the Movies app. Here's the Movies app that you're familiar with. Here are our Cypress tests from last week. And if we look down here, do I have it there? Let's see. Oh, there it is there. Here's my GitLab continuous integration pipeline declaration file. Okay, so it's a YAML file. Not a whole lot of code in it, but it's used then by the GitLab CI platform to, at runtime, it kind of creates the pipeline and executes it for us. So that's how we define our pipeline in this YAML file. And that's just a file like any other file. So as that file changes, then the versions of it can be tracked by Git. Hence, we have version control of our pipeline's evolution. This is just a screenshot from the GitLab CI UI. And so what I'm showing you here, for example, I've got a pipeline and I've executed it a number of times. And it's over here. We can see what the different stages of the pipeline looks like. The pipeline here had 3 stages and they were all successful. And this is what you will see now. Whereas, let's say this one here, it seemed to have failed at the last stage. And then we go debugging as to what was the cause of the failure. If you click on that there, you'll get a look at the console output produced by the jobs within that stage, and that allows you to do your debugging. So if we kind of look down at the bottom of the screen, so on the left, we have our application source code. We commit changes to that source code and push those commits to the GitLab repo. The GitLab then will detect that that repo has the YAML file that describes the continuous integration pipeline. That will cause GitLab to execute what's called the GitLab runner application on a server owned by the GitLab organization, if you like, on the GitLab service. So it'll just pick one of the available servers that it has available to it, and it will run the GitLab runner application on that server, and that GitLab runner will then execute our pipeline for us. We don't need to know anything about the GitLab runner. It's just the platform on which our pipeline gets executed. Okay, so that's just the language of GitLab. It talks about GitLab runners. You can actually install these GitLab runners on your local machine, but we're certainly not going to do that. Why would you? That defeats the whole purpose of the kind of visibility objective of continuous integration. So that's what happens kind of beneath the bonnet, if you like. Make changes to your application source code, commit it to the GitLab repo. GitLab then will detect the YAML file, which will cause it to run an instance of the GitLab runner on an available server, and then provide the YAML file to that GitLab runner, and it executes our pipeline and produces some output. And the output is what we saw there. So I'll leave it at this slide. So the YAML file is, as I showed you there, it's just another file on within your project. It needs to be located though in the base folder of the project. That's where the GitLab cloud service goes looking for it. If it's not there, then if I go back to the previous slide, sorry. If it's not there, then okay, your code is now up in the GitLab repo, but the rest doesn't happen, obviously. If there's no YAML file, then it doesn't bother running the GitLab runner. And if we look inside that file, what it's telling us here is that there are different parts to this YAML file. So the stages part clearly defines what are the different stages that make up this pipeline. And the stages can be called anything you want them to be, but these are meaningful stage names. Install, build, and test has been kind of chopped out there accidentally, but that could be a deploy stage as well. You do have to be careful with YAML that you use the correct indentation and alignment. I think I mentioned that in the lab. The very first line here is the jobs within, if we look at one of these jobs, so both of these at the bottom are examples of jobs within a stage. Now, in the case of this example, I think each of these stages only has one job, but the job is essentially a series of scripts, commands that you want to execute. And I mean, if you look at this one here, npm install, so this is a job within this stage, and we know what npm install does. It installs the node packages. So that must mean that this script executes in an environment that has node installed on it. And that's what the purpose of this very first line in the YAML file is. You can specify, essentially what you're specifying here is a Docker container. I don't know if you've done anything on Docker or not. It doesn't really matter. As far as we're concerned, the purpose of this first line is to ensure that there are certain packages and applications and binaries available to the jobs within our pipeline. And so for this one here, for this job here, it assumes that node has been installed on the server that is running this pipeline. And that line ensures that. Here's another job. This is the job, as you can tell from the name, this is the job that runs the end-to-end tests. And the commands that we are executing are the same kind of commands that we would normally execute from the command line ourselves when we're doing all of this stuff locally. So, we're starting the development server, the React development server, starting in background mode, and then we're running our Cypress tests. In this case, we're running them in what's called headless mode. When you complete this week's lab, which is on Cypress, you will make more sense of what I mean by the headless mode. So as far as we're concerned, in order to achieve continuous integration, we're going to be using the GitLab service. We're going to be writing this file and adding to it. And then the GitLab service does the rest, really. So our job is simply to create this YAML file and the rest, and create the repository as well up in GitLab. And you will be doing that in, well, not next week because we don't have lectures next week, but you'll be doing it in the first lab after the midterm break. Okay, I'm going to stop there. There's just 2 other slides. I might talk a little bit about this one tomorrow morning, and I'll also talk about the assignment specification. Maybe have a quick read of the assignment specification yourselves before tomorrow's lecture in the morning. And then any questions that you have, of course, you can put to me in the actual live meeting or separately on Slack if you have them. Okay, thanks for staying with me, and I'll talk to you again tomorrow.